Hey guys, it's Miss Matheson here, coming at you. It's Sunday afternoon. It's nice and sunny outside. Hope that you've been able to get outside and go enjoy the weather. Today we visited my husband's grandfather from his assisted living. We stood outside and called him and talked to him through the window, colored on his patio sidewalk chalk, and so got to bring a little brightness to his day today. So today I'm going to come at you and give you Unit 2 notes for parallel lines and transversals. Really short. Today is just going to be a lot of definitions and diagrams. And then tomorrow is just going to be kind of like a review of these notes in a little different format. And you're going to do a couple of homework and a partner activity. And then we're going to be done with this. And so we are going to take a really small assessment on it before we get into triangle congruences. All right, so I'm going to share my screen and so that you guys can see my notebook, and we're just going to jump right into writing notes out. So this would just be like if we were in class, but it's just a little bit different because I'm giving it to you off my computer and my notebook. So I'm going to just write, and so I expect you to be writing this into your notebooks also, so that when we are hopefully able to come back together, that we all have the same stuff in our notebook. So I'm just going to turn here to my notebook, and we're going to title this Unit 2, Parallel Lines and Transversals. All right, so let's just talk about what is a transversal. So if I have a set of, first I'm just going to show you just with a general set of lines. And then I'm also going to draw a set of parallel lines. So these ones I know are parallel because I'm throwing in that little extra marking there. All right, so a transversal is the line that cuts through two other lines. So this and this are transversals. It is a line that passes through two lines in the same plane at two distinct points. So a line that passes through, I'm going to slide that up so you can see, passes through two lines in the same plane at two distinct points. All right, so like here is a distinct point, here's a distinct point, here they are here. So we are going to focus on the relationships that are created here and their angle relationships, but we also can name those angles with this one here. They just don't hold the same about statements about their measure. All right, so I'm just going to turn my page here, and I'm going to talk about the relationships that are formed. Now, if I'm going through notes and you miss something and I turn the page, just pause the video or rewind it and do what you need to. All right, so let's jump in here and talk about consecutive interior angles. So consecutive means things that are right next to each other. Interior means inside. And angles, we know that. So consecutive interior angles. So the short version is there are two angles that are on the inside of my parallel lines and they're on the same side. So I'm going to say angles that are interior angles on the same side of the transversal. And we have two sets of these when we look here at our set of parallel lines with a transversal. I'm just going to chop my parallel lines. Okay. And my transversal is going to cut through them. Transversals can go through at any angle. All right, now I'm going to grab, let's see here. Okay, so consecutive interior would be like this one and this one. That's one set of consecutive interior angles. If I look for another set, that would be like this side here. This is another set of consecutive interior angles. Now, consecutive interior angles have a certain relationship with their measures, and consecutive interior angles are supplementary. So we will say consecutive interior angles are supplementary. And so just remember, supplementary means that they add up to 180 degrees. So I'm going to show you an example. I'm just going to draw out a quick example here for consecutive interior angles. And I'm throwing in a transversal. Okay. And so this angle is 60 degrees and this angle is 3x. So these are supplementary. So that means they add up to 180. So my statement, that mathematical statement I would write would be 3x plus 60 equals 180. So subtract your 60 over 3x equals 120. Divide both sides by x and I get 40 degrees for x. Consecutive interior angles. All right, I'm going to change now my page to talk about my next set of angles. And the next ones I'm going to talk about are alternate interior angles. So let me slide back up. Alternate interior angles. So these are similar to consecutive interior angles, except for being, they are not on the same side of the transversal. They're going to be on opposite sides of the transversal. That's where the alternate comes into play. So these are non-adjacent, so not next to each other, angles that lie inside the lines on opposite sides of the transversal. Now, remember, alternate interior angles occur even if my angles aren't parallel. It's just that the measure statement that I write isn't true if they are not parallel. So that only holds true for our parallel lines. So let's go ahead and draw our example. Here, I'm going to put in my transversal in orange. And again, your transversal is just cuts through. And so my examples occurred. This time, one is on this side and one is on this side. So there's an example of alternate interior angles. If I look here and here, here's another example of alternate interior angles. So how many sets of alternate interior angles do we have? We have 2 sets of alternate interior angles. All right, so we can say alternate interior angles, and I'm just going to shorthand that, are congruent. So remember, congruent means that they have the same measure. All right, so let's go ahead and jot ourselves an example. I'm going to slide my paper up. So I have my 2, and this orange statement, remember, is only when it's parallel lines. So my lines are parallel. I'm going to toss a transversal in there. All right, so this one is going to be 139 degrees. And this is 3x. So they are alternate interior because they're on opposite sides of my transversal and they are inside my parallel lines. So they are equal, they're congruent. So 3x equals 139. I'm going to go ahead and divide 139 by 3. So x equals 46 and 1/3. And it is a-okay that we have a decimal or a fraction. We are just fine with that. All right, so we have two more types of angles that we see when we have our transversals. So our next one is going to be alternate exterior angles. So very similar to alternate interior angles, alternate exterior angles. So just like alternate interior angles, we're on opposite sides of our transversals, so are these ones, except for these ones occur outside of my parallel lines, or any my sets of lines. So these are non-adjacent angles that lie on the outside the lines and on opposite sides of the transversal. All right, so if I go ahead and draw my lines, my transversal is coming through in orange. All right, so these ones are on the outside of my parallel lines and on opposite sides of my transversal. So they are both outside the blue lines and on opposite sides of the orange one. And I have another set here in this teal jobs. Okay, alternate exterior angles are also congruent. So they have the same measure. All right, so let's go ahead and look at an example. Now that orange statement, remember, holds true for parallel lines when we have transversal cut through parallel lines. So I'm going to make my lines parallel, drop in my transversal. All right, so 2x plus 1. And this time, we're going to use a little thought process of that. I have my 101 up here. Now, this does not make these two alternate exterior. One of them is interior. But what I'm going to do is use my knowledge about my lines. And I know that this one here is going to be 79 degrees because these two are supplementary. They are a linear pair. So now I have 79 is going to be equal to my 2x plus 1. Subtract over your 1, 2x equals 78, so x equals 39. All right, and our last one are going to be corresponding angles. Corresponding angles. All right. So corresponding angles have the same position relative to the transversal. So angles that have the same position relative to the transversal. Okay, so what does that mean? Let's draw ourselves our lines and throw in our transversal. Okay, so when we have these, they are going to be such an example like here and here. So if I pick up this bottom line and I lay it right on top of the top line, they're in the same position in relationship to the transversal. They are above my line and to the left of my transversal. So that's one set. Here's another set on this side. Okay. And let's throw in, here's another, oops, that's not up it, this one. Sorry about that. We have one, oh, I need to pick different colors. We'll throw this blue in down here and here. And then my last one, I'll make a light peach, is here and here. Okay, so we have 4 sets of corresponding transverse or corresponding angles. Corresponding angles have the same measure, they are congruent. So corresponding angles are congruent. So if you've noticed, we have 3 sets of angles that are congruent and 1 set that is supplementary. And it's those consecutive ones, those are our only supplementary set that we talk about for these angles. So let's go ahead and do our example. So I'm going to scoot this up a little bit. Remember, the orange statement holds true for parallel lines. So I'm going to look at parallel ones and have a transversal cutting through. All right, so this is 2x plus 1, and this is 63. These are corresponding because they are above the line and to the right side of my transversal. So I'm going to set them equal. They have the same measure. Subtract over my 1, so I get 62. So x equals 31. All right, pretty slick with that. And I'm going to pause there for your notes. And then when we get back together for our face-to-face time this week, then we will do some examples together. All right, so review that and be prepared to practice some examples when we are together this week. Bye.